Have you ever seen the sky dance with colors so vivid, it feels like magic? Welcome to the world of auroras. Auroras, also known as the northern and southern lights, are nature's most spectacular light show. These mesmerizing displays are predominantly seen in high-latitude regions around the Arctic and Antarctic. Auroras appear as dynamic patterns of brilliant lights, forming curtains, rays, spirals, or flickers across the sky. But what causes these breathtaking phenomena? It all starts with the solar wind. Disturbances in Earth's magnetosphere, caused by the solar wind, lead to these stunning light displays. Charged particles from the Sun collide with Earth's atmosphere, creating ionization and emitting light. The colors of auroras vary, with green being the most common, followed by red, blue, and purple. At higher altitudes, oxygen emits red light, while at lower altitudes, it emits green. Molecular nitrogen contributes to the blue and purple hues seen in auroras. Auroras are most commonly observed in the auroral zone, a band centered around 67 degrees north and south. During geomagnetic storms, auroras can be seen at much lower latitudes, even as far south as the Mediterranean. The term aurora borealis was coined by Galileo in 1619, combining the names of the Roman goddess of dawn and the Greek god of the north wind. The southern counterpart, aurora australis, is visible from high southern latitudes like Antarctica and Australia. Auroras have been observed on other planets, brown dwarfs, comets, and some natural satellites. Early evidence of a geomagnetic connection to auroras was established by Elias Loomis in 1860. Auroras can be seen directly overhead, or as a greenish glow on the horizon, sometimes faintly red. Different forms of auroras include mild glows, patches, arcs, rays, and coronas. Coronas cover much of the sky and diverge from a single point, creating a breathtaking spectacle. Auroras change with time, starting with glows and progressing to coronas, often fading in reverse order. Pulsating auroras vary in intensity over short timescales, creating a mesmerizing dance of light. Auroras also produce strong radio emissions known as auroral kilometric radiation, observable only from space. In 2016, a new type of aurora called Steve was discovered, caused by a ribbon of hot plasma. Steve is often accompanied by a picket fence aurora, appearing closer to the equator than typical auroras. The Dune aurora, discovered in 2020, consists of parallel stripes of brighter emission, resembling sand dunes. Horse collar auroras form during periods of northward interplanetary magnetic fields, creating teardrop-shaped polar caps. Conjugate auroras are mirror-image auroras found at conjugate points in the northern and southern hemispheres. Auroras result from the interaction of the solar wind with Earth's magnetosphere, creating a dazzling display. The immediate cause of auroral emissions was discovered in 1960, revealing a flux of electrons entering the atmosphere. Auroras have fascinated humans for centuries, with early records dating back to ancient China and Greece. In Aboriginal Australian traditions, auroras are associated with fire and the spirit world. Auroras are a testament to the beauty and mystery of our universe, a celestial dance that captivates us all.